Hello students, let's continue with our optical isomerism topic. Today we will study about the resolution of racemic mixture. Now racemic mixture is actually, as we have already understood, racemic mixture is a mixture of two enantiomers, that is the D and L form of enantiomer. So, usually, whenever we carry out any synthesis, we get the product into the form of racemic mixture. Now, if we want to separate them into D and L forms separately, then such type of requirement is needed in case of when only one particular enantiomer is medicinally important. So now we can define the term resolution. Resolution is actually separation of the racemic mixture into its respective dextro and levo components is called as a resolution. Now since the enantiomers have the same physical properties like solubility, boiling point, melting point, because of that, they cannot be resolved uh, by simple technique like crystallization or distillation or basic chromatography, which techniques are used generally for separation of number of compounds from the mixture. So there are special techniques which are to be adopted to carry out the separation of the racemic mixture. So there are five methods which have been mentioned here, like mechanical separation, biochemical method, chemical method, kinetic method, and selective absorption. So the first one is the mechanical separation. Now, if the dextro and the levo forms of the substance exist in the well crystalline forms, then the separation can be done by adopting this type of method. That means the dextro and levo form should have different crystalline form, and in that case we just can pick up the crystals from the mixture with the help of forceps by using the magnifying lens. For example, the dextro and levo forms of sodium ammonium tartrate can be separated by this type of technique. Now, as we can understand from that, this method is very tedious, and because of that it is having very limited application. So that is about the first method of resolution. The second resolution method is the biochemical method. Now in this method the resolution is effected by destroying one form, either the dextro form or the levo form, by a reaction or by the process that is called as a biochemical process. When certain microorganisms like yeast, molds, and bacteria uh, are allowed into the solution of racemic mixture to grow, then what they will do? They will assimilate one form from the mixture, and they will keep the another form selectively, and thus ultimately one form will be completely utilized by the organism, and the another form will be left in the solution, and after that it can be isolated by fractional recrystallization. So this is one of the useful method, but this is having an disadvantage that of the total mixture, half of the material gets destroyed because that is taken up by the microorganisms. Then comes out the third method, that is chemical method. Now this is the method which is generally used for the resolution of the optical isomers. In this the racemic mixture is mixed with another suitable optically active isomer, and once the reaction is over, it forms two diastereomer salts, and after that they can be separated because of the difference in their properties like solubility and other properties. So, and then it can be recrystallized by fractional crystallization. So, after the separation process, then the diastereomer, actually we have separated our optical isomer into a diastereomer form. So, once the separation is completed, we can convert the diastereomer back into its enantiomer by the suitable treatment with acid. Then comes out the fourth method, that is called as a kinetic method. So when the optically active substance is treated with the racemic mixture, then the enantiomers in the racemic mixture, they react at different rates, and that can be utilized for separation of the mixture. For example, in case of menthol, which is treated with with the racemic mixture of mandelic acid, it is observed that menthol reacts faster with the dextromandelic acid than the levomandelic acid. And in such case, the dextro form of ester, mandelic ester, will be formed faster than the LIGO form. And thus, the product which is obtained will be like the dextro ester more than that of the LIGO ester. And after that, it can be separated. The fifth method is the selective adsorption method. Here, in this case, the racemic mixture is allowed to pass through a column which is binding an adsorbent that is optically active in nature. In such particular setup, the racemic mixture, which upon uh, pouring onto the column will be absorbed, only one enantiomer will get absorbed over the adsorbent, and the another enantiomer will pass down the column into the solution. So this means the separation is easily done as one enantiomer will remain with the adsorbent in the column, and another enantiomer will pass out of the solution down the column lactic acid. Here are few of the important questions to practice, which include like what is stereoisomerism, then what is the racemization, what is about the asymmetric synthesis, and moreover there are certain multiple choice questions which are also important from this topic. These are some of the references. Thank you.